We're live. Hey everybody. This is another video for my Intro to Calc students, and this is our second day of quotient law. We're going to do a couple of examples that are not in your textbook, not in your booklet, just to get you kind of looking at applications with quotient law. And these are the same kind of applications we've been doing for quite some time. Please copy the following question, and if you want to try working ahead, feel free to pause the video and try it yourself. I'll give you a minute. How did it go? All right. So let's see how this works. Find the equation of the tangent to the curve. Oh, we've seen this before. The tangent to the curve when x equals 1 is going to be the value of the x being 1 in the derivative of this. So that'll be the slope, and then of course we need to find the y-coordinate when x is 1. So maybe I'll just do that first and get it out of the way. How much is the y-coordinate when x is 1 for this particular thing? So let's see, y equals 2 times 1 all over 3 minus 1 squared, which is 2 over 2, which is, oh, that's a nice point. It's the point 1, 1. And we'll call that x1 and y1, and you'll see why when we get further down. Now I, of course, need, if I'm going to use the point slope formula, spoiler for this, then I need to know what the actual slope is, and the slope is the derivative of this. So, all right, how does the derivative law work again? Well, let's see. It is the bottom, 3 minus x squared, times the derivative of the top, 2, minus the top times the derivative of the bottom, negative 2x, all over the bottom squared. All right. Now you're probably thinking, man, these problems were tough enough before you added this stuff to it. Actually, in a weird way, this additional context to the problem actually makes this easier, because remember yesterday, one of the toughest parts of these problems was figuring out how far to simplify the answer if I'm going to be working from a textbook and try to see if my answer is the same as the answer in the textbook. I have a goal here that kind of goes beyond just looking at this and simplifying it. I'm actually going to have to plug in what happens when x is 1. So I'm just going to tidy it up a little, see what it looks like. I'll distribute that, so that's going to be 6 minus 2x squared plus 4x squared all over, and I'm not going to bother expanding this binomial. Okay, so y primed is actually 6 plus 2x squared all over 3 minus x squared squared. Okay, oh, sorry, I'm off the screen. There we go. There's our derivative. And as I've been telling you from the start of this, I don't mind when you're doing your homework if you take a little Desmos trip and just double check to see if you have your answer right before you even look in the back. Go to your Desmos. That's not my Desmos. There's my Desmos. Go to my Desmos where I've already kind of pre-planned this. So there's my original curve. Isn't it lovely? And there's what Desmos says the derivative is. Let me get the original curve out of the way. And here's what I just calculated the derivative to be. And yay, notice the black turned green, green, black, green, black, green, black. So I definitely have the right answer, at least according to Desmos. So happy in that knowledge, I'm going to continue my quest to find the equation of the tangent. Let me just kind of go back to Desmos for one quick second here. So again, what am I looking for? I'm looking for the tangent to the curve at the point 1, 1. Where are you? 1, 1, 1, 1, 1, 1, 1, 1. There, right there. So, okay, I'm expecting something not too terribly steep and with coefficients that are not too terribly ugly. So there we go. That's what I'm expecting. Let's see if that's what we get. Okay, back to the work. So that's my slope. I need the slope when x is 1. So let's find that. So m is going to be equal to 6 plus 2 times 1 squared all over 3 minus 1 squared, which is 6 plus 2, which is 8, all over 3 minus 1, which is 2, but the 2 is being squared, so that's 4. So that is nice. My slope is 2. So I have an m, I have an x1 and a y1. I'm ready for the point slope formula. Y minus 1 is equal to m times x minus 1. Simplify that out a little. Y minus 1 is equal to 2x minus 2, and 2x minus y minus 1 is equal to 0. Let's see if that works with my slope here. I'll just do that as 2x minus y minus 1 equals 0. And yep, there it is. It goes right through 1, 1. It's a tangent. It's beautiful. It's done. Mission accomplished. So there's the first example. We're only going to do a couple today. And yesterday's video was long enough for 2 days. So today's will be short. All right, so that was example, actually that's example 4 if we continue from yesterday's notes. Example blank page for some reason. There we go. Example 5. I'll give you a second. Just pause the video and copy that one out, please. This one's a little more interesting, a little more wordy. The graph of the curve y equals x squared minus 2x all over x squared plus x plus 1 has a maximum and a minimum between x equals negative 2 and x equals 2. Find the x coordinates of these points. And boy, when I first read that problem, I thought, now that's interesting. And I got to admit, I cheated. Rather than starting the work, I decided to go to Desmos first because I just wanted to see what the curve looked like. And so I graphed it, and sure enough, yeah, look at that. There's negative 2 and 2. And yeah, between those 2 points, there is a maximum around here someplace. Oh, there it gives it to us. And there's a minimum. I won't click on the point anymore, so you didn't see that. I kind of don't want to be giving that much away. But I want to know the x coordinates of those 2 points. So that's the job here. And think about it. What do I know about the x coordinates of those points? Well, those points are maximums. They are the peaks. And that means that they're tangents or horizontal. And what do you know about the slope of a horizontal line? It would be 0. So that's my goal for this question. My goal for this question is to find the derivative of this and set it to 0, then solve for x. Oh, well, that sounds like fun, so let's do it. So, step 1, we break out the quotient law, which is the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. And I don't know if you can tell by now, but I have not too much patience for bothering to square out the bottoms of these things. I mean, I wouldn't do it when I was a binomial. I'm certainly not going to do it when it's trinomial. But I'd also look to see, is there any cancels or anything that'll make this simpler? I mean, you know, this does share a factor with that, but I don't think this will make a factor of that. I'll play with it and see what happens. I will expand it out and see what condition my condition's in once I'm done that. Okay, so I played with this on another piece of paper, which I seem to have completely misplaced. There it is. I just want to make sure I don't goof it up. Okay, so multiplying this out. First times all of that is going to be 2x cubed. And then 2x times that is 2x squared. Plus 2x times 1 is 2x. Then the minus 2 times everything. So minus 2x squared minus 2x minus 2. Phew, that's all that. Minus, and I learned my lesson from the last video where I made like 4 errors. I'm just going to do this multiply first, do it all in one bracket, and then I'll distribute the negative. I won't try to do 2 steps at once. So there's going to be 2x cubed plus an x squared, right? First times first, outside times outside. Inside times inside is minus 4x squared, and last times last is minus 2x. All of that over the denominator that I don't feel like playing with. So, let's collect our like terms. We have a 2x cubed minus a 2x cubed. Hey, no x cubes. Isn't that nice? And when we collect our like terms, we have, let's see, a 2x squared minus an x. Oh, wait a minute. We have more than that. We have a 2x. Oh, here. These go away. 2x squared, 2x squared. And then we have, let's see, what else do we have? We have a 2, no more x squareds there. We have a minus negative, okay, so let's put that together. That's x squared minus 4x squared is negative 3x squared, but I'm minusing the negative, so that's 3x squared. And then I have, oh, that 2x minus 2x, I missed that cancel. And then I have minus a negative 2x, which is plus 2x. And then I have a minus 2. And there, I think that took care of everything on the top. Looking at yesterday's notes, yep, that works. And then the bottom is this. And I don't think the top is factorable or anything. Oops, I'm sorry, I'm off the screen. I don't think that the top is factorable or anything, and it certainly wouldn't cancel anything on the bottom, so I'm just going to leave it. That's my final answer. Well, that's my final answer for the derivative. Again, I don't really need to worry about what state this is in because I am doing something with it. Remember, this is the equation of the slope, and that slope has to be 0 if the tangent's horizontal. So solving for this equation when this thing equals 0, I can just cross multiply this. This times 0 is 0. So I am solving for x in this equation. And it's a quadratic equation. And man, wouldn't it be nice if it factored? But I don't think it does. There are not two numbers at times to make -6 that add to make 2 in the land of whole numbers or integers. So I am going to break out the good old quadratic formula. So that's minus b plus or minus the square root of b squared minus 4ac all over 2a. Which is, let's simplify that, that's -2 plus or minus, that's 12, 24, 24 plus 4 is 28 over 6. 28 has a perfect square in it. It's got a 4, so let's take the 4 out, which becomes a 2. And then we can factor a 2 out of the top, cancel it in the bottom, and there's the final answer for the two x coordinates. Notice there is two numbers, right, because it's plus or minus. And there's my final answer. It's -1 plus or minus root 7 over 3. And just like the other problem, I kind of want to see if I did this right. So I'm going to just jump over to Desmos here. And okay, so let's get to this. So first of all, there's that wacky curve. There is what Desmos says the derivative is. And here's what I got. And look at that. It's the same. So I had the right derivative. And here is, okay, I can make the derivative go away. Here is the tangent line. Oh, wait a minute. That's for the other problem. I don't want that. Go away. Yeah. Here is what I think. Now, you're probably wondering, how am I going to find these peaks exactly? Well, here's the trick. I know that these peaks exist when the slope is 0, and the slope is f prime of x. So I'm just going to say, hey, Desmos, tell me when f prime of x is 0. And it's going to give me those two lines. And then I just look for where they meet. And they meet at, oh, yeah, but it's not going to give me radicals, is it? Well, okay, we can do that. I don't know if you know this or not, but Desmos can be used as just a everyday calculator if you like to. So I got -1 plus square root of 7 all over 3, and that's 0.54. So the positive one should be 0.54, and it is 0.54. They round it to 9, but there's the exact answer right there. And then the other answer, the negative one over here, would be, let's see. Whoops. Negative 1.215. Is that what that point is? They don't even give me that many decimals, but yep. Whoop, go away. But that's what it is. So there we go. We got it. So there's a couple of nice little application problems for quotient law. Keep on trucking through that homework, and we'll see you in the live chats. Bye-bye.